On the last page, we'll review law of sines and law of cosines. So for number 1, we're given that angle A is 36 degrees, side A is 8, and side C is 5. So we know that we'll only have one solution for angle C because we're given an acute angle where the opposite side is greater than the adjacent side. And we know that A is the opposite side because it is the same letter as angle A. So we have a triangle, and we know that A is 36 degrees, side A is 8, and angle C we're looking for, and side C is 5. We can set up a law of sines proportion to help us find the angle C. So we are going to do the sine of 36 divided by 8 equals the sine of C divided by 5. So when we cross multiply, we'll get sine C equals 5 times the sine of 36 degrees all over 8. And we need to leave our answer in calculator ready form. So if you were to put this in the calculator to find angle C, you would take the inverse sine. So we have the inverse sine of 5 times the sine of 36 degrees all over 8 as our final answer. For number 2, we need to use the law of cosines to find our missing angle. And in this case, we're looking for the largest angle. So we know that the largest angle will be angle C since C is the largest side. And for law of cosines, we always will have one solution. We don't have to worry about an ambiguous case where we would have two solutions. So if we have a triangle with sides 11, 9, and 3, we can use law of cosines to find angle C. So we're going to use C squared equals A squared plus B squared minus 2AB sine C. So 11 squared equals 9 squared plus 3 squared minus 2 times 9 times 3 times the sine of C. So we have 121 equals 81 plus 9, so 90, minus 2 times 9, which is maybe easier. 2 times 3 is 6. 6 times 9 is 54. So minus 54 sine C. So then we want to subtract 90. So we have 31 equals negative 54 sine C. So negative 31 over 54 equals sine C. And then for our final answer, we want it in calculator ready form. So it would be C equals the inverse sine of negative 31 over 54.